Okay, this is on graphing rational functions. So if you go to the back of your packet for graphing rational functions, I'm going to do one with a slant asymptote, and then I'll do one, at least one off of your page that we didn't do today. So this is just another example. If I have y equals x squared minus 4x over, let's say, x plus 1. Alright, so a vertical asymptote appears to be at x equals -1. Let me check the top, x times x minus 4 over x plus 1. And so there's no hole in the graph, because when you fill in -1, you only get 0 in the bottom. So I have a vertical asymptote at x equals -1. The horizontal asymptote, there is none because the top is 1 higher than the bottom. There is a slant asymptote since the top is 1 higher than the bottom. So you go x squared minus 4x plus 0 divided by x plus 1. You account for everything that's missing, like I have x to the second, x to the first, but I didn't have a constant, so I put in plus 0. Then I see how many times x goes into x squared, and it goes in x times. Multiply this, gives you x squared plus x, and then subtract. That cancels, and you get negative 5x plus 0. So you need to turn x into negative 5x, so you need minus 5. That gives you negative 5x minus 5. And then you don't care what your remainder is, you're finished at that point. So you have y equals x minus 5 as your slant asymptote. And so you would have this as your slanted asymptote, which we could type it into our calculator, but I'm going to just find some points in my head. Like for instance, if I put in 0 for x, the whole top is 0 over 1, so I have an x-intercept and a y-intercept there. If I set it equal to 0, the original equation, and cross multiply, I get x plus 1 equals x squared minus 4x. So I get 0 equals x squared minus 3 minus 5x minus 1, which you could try to factor, but I don't think it has any other zeros. It might have another one out here. So let's go to our calculator and check that out. X squared minus 5x minus 1, you couldn't factor, so it might have like decimal value zeros. Alright, always put in your original, x squared minus 4x. So parentheses, x squared minus 4x divided by x plus 1. Okay, I'm going to go to table and verify. We've already filled in 0. We should have gotten 0. Oh, I don't think this one's on auto ask. Let's see. Ask auto. Alright, so we can ask our own stuff. 0. Let's see what happens at 1. At 1, I get negative 1.5, so it must have another 0. I'll show you how I know that. Let's see, at 1, I got negative 1.5, and so it has to probably come down through here and go back up this way. So let's fill in 2. So I'm going back to my calculator. I'm going to fill in 2. And I get negative 1 1/3. If I fill in 3, I get negative 3/4. If I fill in 4, I get 0. Oh, wait, I must have done something wrong. I'll go back to it. Oh, I see what I did wrong. I'm sorry. Right here. Sorry. Right here, when I cross multiplied, that right there is 0. So I had 0 equals x squared minus 4x. I should have known that. When I cross multiplied, that's 0. So I factor out an x. And so I have a 0 at 0 and at 4. So it comes down like this and comes back up and follows that slant asymptote. Now there's got to be something over here also. So I'm going to fill in -2 and -3 and see what's going on over there. -2, oops, second table. Oh, let me quit. Table. -2 gives me -12, -3 gives me -10. Let's put in -6 and -5, just looking at where it is. All right, so let's put in some of those points and see if we can make sense of this. -2, -12. Let's see, 6, 7, 8, 9, 10, 11, 12. Okay, so it's sitting right down in here if I found these points into that pocket. All right, at that point you may want to look at graph. And then you probably going to hit zoom 6. And now we don't see the other part. That's why you don't want to trust your graphing calculator, trust yourself. But I know that it's there because I used my best friend table. And now I can see what I thought was there. But I already knew that from asking table. All right, now so with a slant asymptote, if the top is one higher than the bottom, do long division, which I think there's some practice on Delta Math, and watch out for zero coefficients. I honestly don't remember if there's a slant asymptote on the exam, but I just wanted to go over that. All right, let's look at number 5. Number 5 is y is equal to x minus 4 over x squared minus 3x, which gives me x minus 4 over x times x minus 3. So there's no hole in the graph because my zeros are all different. Vertical asymptote at x equals 0 and at x equals 3, what makes the bottom 0. And it also, these don't make the top 0. So x equals 0 and x equals 3. All right, since it's bottom heavy, it has a horizontal asymptote of y equals 0. It can't have a slant and a horizontal. So y equals 0 is my horizontal asymptote. I can check for cross. 0 equals x minus 4 over x squared minus 3x. X minus 4 equals 0. So it does cross at x equals 4. It's going to hit that asymptote somehow. And now I'm going to find some points. So don't forget to put your new equation in, x minus 4 divided by x squared minus 3x. I'm not going to be fooled by my graph. I'm going to go to my calculator and find points all around my asymptote. So I'm going to go to table. All right, so points I want to know if I look at my graph. I want to know what's going on at 1 and 2. So I'll fill in 1 and 2. All right, so I get 1, 1.5, and 2, 1. So I get 1, 1.5, and 2, 1. And so I'm guessing it fits in here somewhere. Like if I fill in 3, I should get error. If I typed it in the right way, 3 gives me error. But if I get closer to 3, like 2.999, it should get higher and higher. Yeah. All right, now I want to know what's going on before 0 back here. So I'm going to put in -1 and -2. -1. You can fill in whatever you want to in your expiration. -1 is -1 1/4. All right, so -1, -1, -2. So this fits in here because we know it only crosses right here. And so now I'm going to fill in some other numbers, like if I fill in 4 out this way, 4 should give me 0. 5 gives me 0.1. look what happens if I fill in 3.5. 3.5 gives me negative 0.2. So what's happening is this one's coming from the negatives. It crosses and then hovers on the asymptote like this.